A lever system involves an effort that is applied in tendons. Yes, it is generated by muscles, but you need to focus on where it applies, and that is in tendons. It also involves a fulcrum, also known as the turning point, and a load or resistance. For first-class levers, the fulcrum is in the middle, and it doesn't really matter where the effort or the load are, so the side does not matter. It also has a mechanical disadvantage, which means lifting less weight with the same amount of effort, but benefiting from speed and range of motion. Lastly, this would be the formula for mechanical advantage or disadvantage. So if you get a maths question on this, you would substitute the values using this formula. The tricep pushdown is a good example of a first-class lever. So here, if you don't know the exercise, all you're going to do is grab the handle here and pull it down so that the weight goes up, okay? And here, the effort is generated by the triceps, but is actually applied in the tricep tendon, okay? So don't get it confused. The fulcrum is in the middle as the elbow joint, as should be in a first-class lever. And lastly, we have that the resistance is applied in the handle. This is the weight, yes, but it is not where the resistance is applied. In a second-class lever, because the load is in the middle, remember that the sides do not matter, it has a mechanical advantage, which is essentially the opposite of a mechanical disadvantage, having opposite benefits and drawbacks. So here you might lift more weight, but you'll have less speed and range of motion. Plantar flexion or calf raises are an example of a second-class lever because the effort is on the side applied by the Achilles tendon. Yes, it is generated by the gastrocnemius muscle, but it applies here. Then we have the body weight, not the load. This is what causes the load, which points downwards in the middle. And then lastly, we have the fulcrum also on the side, which is the joint around the metaphalanges and phalanges. So just focus on the load, which is in the middle. We've seen before that first-class levers have the fulcrum in the middle, second-class levers have the load in the middle, but this time the effort is in the middle for third-class levers, and this means it also has a mechanical disadvantage. A bicep curl would be an example of a third-class lever because the effort is in the middle, as you can see here. Yes, it is generated by the biceps, but it is not where the force applies. Therefore, it applies to the tendon around here, which will cause the movement.